Assalamu alaikum. I am Maham 231843 from PMTS 4B. My group members are Muhammad Furqan and Abdullah Khan, or my project supervisors are Sir Umar Farooq and Ma'am Sadia Saeed. Today I will discuss about, first of all, team roles and details. Team lead, I am Maham Tanveer. I do work on schematics plus Proteus and giving the support to my group members. Project manager is Abdullah Khan. He do our sourcing plus theoretical. Our technician is Muhammad Furqan. He has very good command on hardware and PCB plus report writing. Integrator and testers, we all three. Then I will discuss about abstracts table of content. The report presents the design, development, and implementation of REHBER, a multifunctional autonomous line follower and obstacle avoiding robot. REHBER integrates a range of sensors and embedded systems on a custom designed PCB to achieve intelligent navigation, real-time monitoring, and data logging. The robot follows a black line on a white surface using 3 infrared sensors and employs an ultrasonic sensor HCSR04 to detect obstacle along its path. Upon detecting an obstacle, REHBER slows down, uses calibrated color sensors to identify the color of object and executes the path avoiding maneuver before resuming line tracking. 2 optical RPM sensors provide real on wheel rotational enabling distance and speed estimation. Power is supplied via 3 18650 Leon cells with regulated 5-volt distribution using 7805 IC for speed, voltage, current, detected colors, and path status. All runtime data such as voltage, current, speed simultaneously transmitted to an IP interface via an ESP32, allowing remote monitoring through a web server hosted on a ESP module. Communication between ESP32 and dual Arduino Unos is directional via UART, ensuring timely data transfer for display and storage. The robot embodies key principles in robotics, embedded systems, power management, and sensor integration, making in a complete platform for autonomous mobile system research and development. So our first chapter, our first heading is preliminaries. First of all, 1.1 is proposal. The goal of this project is to design and implement the line following robot, a multifunctional autonomous mobile robots capable of line tracking, obstacle detection and avoidance, color identification, speed monitoring, power tracking, data logging, and real-time telemetry over IP. REHBER is intended for educational, industrial, and research applications where sensor integration, autonomous navigation, and real-time system monitoring are critical. It is built around dual Arduino Uno microcontrollers and ESP32 module, a costume PSB, and a range sensor, all mounted on the self-designed chassis. Initially, first of all, the feasibility analysis considered 3 main aspects. Technical feasibility: the components selected Arduino Uno, ESP32, L298. IR sensors are widely supported with reliable libraries and examples. The embedded design is achievable using commonly available fabrication and assembly tools. Wi-Fi communication via ESP232 is also robust and support lightweight HTTP based web server hosting. Economic feasibility: the total cost of the material remain within the moderate student project budget with many components reusable. The use of 18650 cells and minimal LCDs display avoids the cost of advanced display modules or commercial motor drivers. Operation feasibility: the robot in user-friendly, adaptable, and real-world path following and educational demonstrations. It offers a scalable platform that can be modified to perform more complex tasks, e.g. payload, delivery route optimizations. Then comparison table with similar products. Line follower: 3 sensors, 8 IR sensor and 3 IR sensor, color plus IR board. Then obstacle avoidance, color detection, RPM and speed sensing, data logging, real-time web monitoring. Monitoring power systems microcontroller chases. First of all, I am talking about technical standards about IR sensor. The function of IR sensor detects the contrast between a black line and white surface using infrared reflections. Operating voltage is 3 volts to 5 volts. Detect Detection range is 2 mm to 15 mm. Output type is digital, low for white and high for black in your case. Response time less than 1 millisecond. Typical use is line tracking navigation. Then we have and driver module to discuss. First of all, function, control, direction and speed of two DC motors using PWM. Operating voltage is logic 5 volt, motor 5 volt to 35 volt. Maximum current per channel is 2 ampere, peak 3 ampere. Short duration, number of channels is 2. Control inputs 4 digital signals, and typical use is bidirectional motor driving. Then we have ultrasonic sensor. Function is measuring distance to obstacle using ultrasonic waves. Operating voltage is 5 volt, which is direct. Operating current is 15 milliampere. Detection range is 2 centimeter to 400 centimeters. Accuracy is plus minus 3 mm. Measuring angle is 15 degrees. Response time is 50 ms. Trigger echo pins is digital input output. Typical use is obstacle detection and avoidance. Then we have color sensor. Function is detect RGB color values using photodiodes and filters. Operating voltage is 3 volt to 5.5 volt. Output type is frequency 100 to 600 kilohertz depending on color intensity. Then photodiodes, which are red, green, blue and clear. Frequency scaling are 100%, 20% and 2%. Typical uses color identification and classifications. Then we have optical RPM sensors. Functions measures wheel rotation and calculates RPM distance. Sensor type is infrared slotted on reflected type. Output type is 3 digital pulses per revolution. Operating voltage is 5 volt. Typical pulse count is depend upon encoder wheel slots. Accuracy depend on wheel. Typical use is speed, distance and position estimation. Then we have voltage sensor, typically LM2596 based on driver module divider module. Function monitor voltage level of a battery pack. Operating voltage up to 25 volts. Output voltage scaled analog voltage to 5 volt. Typical accuracy depend on calibration. Typical use battery level monitoring and display. Then we have current sensor. Its function is measuring current. Its variants are 5 ampere, 20 ampere and 30 ampere. Output type analog voltage. Sensitivity 185 millivolt per ampere. Accuracy 1.5 depend on the filter and calibration. Typical use power monitoring, safely diagnostic. Then we have 16 by 2 LCD display. Function display robots telemetry like speed, voltage, color etc. Operating voltage is 5 volt. Communication mode is 8-bit parallel. Character is 16 character per line, 2 line. Backlight LED based operational control. Typical uses status and sensor data display. Then we have microcontroller. Function hosts web server and transmits data over IP. Operating voltage is 3.3 volt. Logic Wi-Fi protocols IEEE. Flash memory is 4 MBs. And then we have GPIOs 30 plus and analog channels 12-bit. CPU dual core 10 silica. Typical use web interface, Wi-Fi communication, SD logging. Arduino Uno, as you all know about Arduino Uno, functions main control for motor and sensor logics. At Mega 328P microcontroller we used. Operating voltage is 5 volt. Clock speed is 16 megahertz. Flash memory is 32 kilobytes. GPUs 14 digital 6 analog inputs. Communication UART SPI 12C. Typical use line following logic sensors. Then we have micro SD card module. Its function is logs, robot, data in plain and text format, operating voltage 3.3 volt, logic file format, typical. These all things are discussed here. Then we have work breakdown structure. First, project management. A project planning, scheduling, position, project manager. Name Abdullah Khan. Role, define project timeline, allocates resources and set milestones. Outstanding component. Outsourcing component is also done by Abdullah Khan. Then report writing, theoretical section. The report writing project manager Abdullah Khan compiles theoretical part of the report including background of the methodology. Then we have schematic design, position, team member. As I am the team member of for this post, my role is develop the electrical schematics of the robot including sensors and drive layouts, and honestly it is very tough tasks to do. Simulation and testing Proteus. I simulates the design schematics in Proteus to verify circuit behavior. Then I design PCB layout and prepare for fabrication. Hardware development done by Muhammad Furqan. He assembles components including sensors, motor drivers and connectors. The fabrication is also done by Muhammad Furqan. Fabricate the PCB and ensure functionality through quick checks. Then chassis assembly Muhammad Furqan, done by Muhammad Furqan. He do mount and secure all components on the costume or source chassis. Then sensors calibration. I calibrate IR and color sensor for reliable operations. Then Muhammad Furqan verify motor operator via L298 and driver and correct any error. Full system integration done by Muhammad Furqan. Me and Abdullah Khan combine all subsystems, electrical sensors, motors, and validate full robot function. Then troubleshooting and optimization. And troubleshooting is done by all the team members collaborating, debug and tune for robot logic. And then we have documentation and reporting. Theoretical background, as I discussed before, then that Abdullah Khan is theoretical for theoretical background, draft explanation of underlying principles such as line following, sensor behavior, and robot control. Then final report writing is done by a technician plus team member. Muhammad Furqan and me compile full project report including objectives, design methodology and conclusions. Then presentation preparation is done by our project manager who is Abdullah Khan, design the deliver, and final presentation summarization, key project highlights. Then I have estimated budget about my project. We purchased Radino Uno for 1900 per product and 3800